These are solutions to Melham's Math 75 at City College, exam number 3, the third exam. Number 1, limit as x approaches 5 of x squared minus 25 over x minus 5. First thing you want to do is factor the numerator. The numerator factors into x plus 5, x minus 5, and then very conveniently you can cancel these out. So then you can plug in. So limit as x approaches 5 of x plus 5. Plug in 5, you have 5 plus 5, so the answer is 10. Number 2, given this function, is it continuous at x equals 2? So you have a piecewise defined function. The function is x minus 5 if x is less than or equal to 2, 3x minus 10 if x is greater than 2. Well, let's see what happens in the limit as x approaches 2, both from the left and from the right. If I approach 2 from the left, I'm using this function. If I approach 2 from the right, I'm using this function, but you can see that we get different values. So the limit as x approaches 2 from the left means I plug in 2 to the top function. It would be 2 minus 5, which is negative 3. The limit as x approaches 2 from the right, however, I'll be using the bottom function, 3x minus 10. So 3 times 2 minus 10, 6 minus 10 is negative 4. And as you can see, these two values are different. So the two-sided limit does not exist. Since the limit does not exist, d and e, that tells me that the function is not continuous. Number 3, give the average rate of change of f of x equals x squared over the interval from 2 to 2.01. You're basically just taking the slope of the line that passes through 2 comma f of 2, 2.01 comma f of 2.01. You just plug in. 2 squared comes out to be 4. 2.01 squared is 4.0401. So it's just y2 minus y1 divided by x2 minus x1. If you work that out, it comes out to be 4.01. They say make a guess for the instantaneous rate of change. Well, we picked two numbers that were real close by, 2 and 2.01. We got 4.01, so a good guesstimate would be 4. 4 just simply asks for the derivative. So the derivative of this is 0. This one is negative 24x squared minus 12x minus 1. So negative 24x squared minus 12x minus 1. Number 5, give the slope of the tangent line, 3x squared minus 4x plus 7 at x equals 5. So I take the derivative and plug in 5. The derivative is 6x minus 4. 6x minus 4, plug in 5. 6 times 5 is 30. 30 minus 4 is 26. Number 6, use the product rule, but don't simplify. Copy the first function times the derivative of the second. So the derivative of the second looks like it's 6x minus 16. So here I copied the first function and then times the derivative of the second, plus the other way around, plus second function, copy that, and then times the derivative of this, which is 12x squared minus 12x plus 11. So that's what we have here. Okay, so first times the derivative of the second, plus the second times the derivative of the first. Okay, number 7, use the quotient rule, and it tells us to simplify this time. Okay, so it's the bottom times the derivative of the top, which is 2x, x squared plus 5 times 2x, minus the top times the derivative of the bottom, which is also 2x, all over the square of the denominator, x squared plus 5 squared. Okay, clean up the top. Again, normally you don't have to multiply out the bottom. So this becomes 2x cubed plus 10x. Distribute here, minus 2x cubed plus 6x, because it's a double negative, minus 3 times 2x is plus 6x. Notice the 2x cubes cancel out. So I have 10x plus 6x, 16x over x squared plus 5 squared. Number 8, find the derivative of square root of 6x minus 3. That should be treated as 6x minus 3 to the 1/2 power. So chain rule, f prime of x is 1/2, 6x minus 3 to the negative 1/2, times the derivative of the inside, which is 6. Clean it up, 1/2 times 6 is 3. That goes downstairs as a square root. So final answer, 3 over square root of 6x minus 3. Number 9, write the equation of the tangent line to the curve. f of x equals x squared minus 10x plus 13 at the point 1, 4. Okay, so you have the point. I need the slope, and then I throw it into the point slope form. Okay, so the slope derivative is 2x minus 10. 2x minus 10. Then I plug in 1. 2 minus 10 is negative 8. So that's my slope. So y minus y1 equals m times x minus x1. You could leave it like that, or if you want to do some more algebra, y equals negative 8x plus 12. And finally, number 10. Suppose you have this cost function, find the marginal cost, take the derivative, plug in 6. The derivative is 11 plus 10x, 11 plus 10x, plug in 6, 11 plus 10 times 6, 11 plus 60, 71 is the answer to number 10. All right, so these are the solutions to Melham's Math 75, exam number 3.